Alright, welcome back. So, a little bit of a break in the video there because actually my camera battery ran out. And I didn't have the charging cable, so I had to go home, and it's the next day, and I actually brought a lab assistant today who's going to help out with this one. So what you can see is as our reaction mixture cooled down, we had a good amount of this yellow solid form. And then I added the 15 mils of hot water once it cooled down below 100 degrees Celsius. And that quenched the reaction or stopped it from keeping going. And so what we want to do is we want to collect this solid and get rid of most of the solvent. This is, or should be, intermediate 2 from the reaction. So I'm going to use a Hirsch funnel. Looks like it should be approximately the right size, but I have a bigger volume. So instead of using one of these little guys, I've got a much bigger flask on here to collect that volume so I don't have to replace it. However, the Hirsch funnel doesn't seal with that very well, so there's a rubber adapter on there for that. All right, we're on the vacuum. Get our vacuum going here. Right. I may have a little trouble getting stuff transferred because it's been settling all night. This is the wax coating there. If we don't get it all to transfer, that's okay. But we do want most of it if we can. Woo! Sneaky chemistry. So I ruined the hood. Okay, it's getting pretty thick now. Now, a lot of times, when we clean this out or use a new one, we're actually going to use the same test tube for the second part. But hopefully, yep, there we go. We're supposed to have a light yellow to orange intermediate. So I'm going to pick you up. And there you go. There's our product. Okay. So we don't need to get it very dry. The idea here was just to get it most of the solvent off. So I'm going to turn that off. Okay. Now we're going to put this back into here. Yep. We can break the seal. There we go. We got a good vacuum there. And here is our, ooh, look, we got a lot of this product. That's good. All right, we're going to put that back in. All right, there we go. So now, hopefully this is not too dizzying, but we're going to go back across the lab over to the hood that we're doing our reactions in. Okay, so here is our material. I'm going to set it in this so you can see it. So now we've made intermediate 2. We need to convert it into the final luminol here. So we need some sodium hydroxide. This is 10% sodium hydroxide. This is really nasty stuff. This is like Drano. Interestingly, bases can cause burns just like acids, but they're actually worse burns because your body doesn't realize it's been burned, so it doesn't try to heal it. So you have to be really careful with that. All right, we're going to add 5 milliliters. Again, approximate amount, so this pipette will be good enough. There's 2.5 milliliters. Whoa, that's not what you're supposed to do. Good catch. Okay. The other thing about sodium hydroxide, it's slippery. We almost had to start the whole thing over again. Joys of chemistry. What we got? Okay. Now, we added our sodium hydroxide, and it looks like most things have dissolved. And we've got a nice dark red color here, the reddish brown color there. Interesting. Okay. All right. Now we're going to stir this, and you don't ever want to use your thermometer as a stirring rod. It's tempting, but it also causes lots of problems because the thermometers break easily. So let's stir some. Keep the paper towel there for that. I think I'm actually going to do a little better with this. Okay. And so we need to note any color changes. As always, record that in your notebook. I don't know, what do you call that? Brown, red, maroon, dark red. I'm recording this and it's not too far away from Halloween, so blood red. There we go. Okay. All right, what do we add next to this? Next, we put in 2.5 to 3 grams. And I've weighed it out, and I will give you the data. But again, like I said, I often write my masses and things on the bottle when I'm there, or you can do it in Mentress or a notebook, or you can put it in your notebook. going to keep track of it. So we're going to put in 2.5 to 3 grams of fresh sodium hydrosulfite dihydrate, Na2S2O4.2H2O. Some of this is probably going to stick to the sides, but that's okay. We're going to use a little DI water. And we can use the water because there's already water in here, right? The sodium hydroxide was dissolved in water. Ooh, color change again. Okay. All right, so I'm going to once again, as always, use a little bit of my solvent to clean out the container that I had it sitting in, to make sure I rinse over as much as I can. Okay, ooh, that's pretty full. We've gone to yellow. Now, interestingly, I'm actually getting some product forming already. This is, on the bottom here, my luminol. But I want to get even more, and so we're going to reflux this for about 5 minutes. So I have to be careful. I can't do a very vigorous reflux because I don't have very much space in the top of the tube. The other thing is that was fairly concentrated sodium hydroxide, and this is an exothermic reaction. And I know it's exothermic because the test tube got hot, so it's giving off heat. But we're going to go ahead and bring this up to a boiling temperature. All right, welcome back. So I went ahead and took a little break there because it was taking forever to heat this test tube up, and I didn't think you really wanted to watch it just heat up, even at 1,000 times speed. So I just wanted to let you see here we do have the reflux that's going. So we've got nice bubbling going on. I've got a thermometer in here to kind of monitor the temperature at the bottom because there's a very large temperature gradient here where it's about 102 at the bottom, but only about 70 at the top. So this cools down pretty quick. So if I... All right, we are at 5 minutes, so it's time to stop this. I'm going to go ahead and take the heat off. Likewise, I'm actually going to also lift this up so it cools down a little faster. I want to drop the temperature below about 100 degrees Celsius, and then let it, as I said, let it cool just a moment, and then we're going to add glacial acetic acid to this. Now, glacial acetic acid, even though acetic acid is just the acid that's in salad dressing, that is really low concentration, 5% weight per volume. This is glacial. This is concentrated. It's as concentrated as you can get. And I think that's 17 molar. I love the label on this. Caution, causes nasty skin burns. So that's why I'm wearing my gloves. I'm going to add 2 milliliters of the glacial acetic acid. Take the thermometer out when I do that. Wipe it off before putting it down. Right. 2 milliliters. Nope, that one's in the way. Okay. Stir this a little bit. We're going to use the finger tap method there. I could use my glass stir rod as well. And then we're going to start to cool this down by running it under tap water. As we do this, we should see the solids start to crash out. And in fact, there you go. There's our solid luminol coming out as it cools down. Have the camera in here because there's a lot of solid forming as I do that. Okay. Mostly cold, but I'm going to go ahead and set this in an ice water bath. I think we got a good amount, so let's come on over to the filter place again. Now I put a new filter on here because our product is the solid, and I'm actually going to let this sit just a moment more because I want to have as much product as I can because I want my luminol to really, really work. In fact, let's grab a little more ice. See, chemistry's cool. Sorry, couldn't resist. Yeah, dad jokes and chemistry jokes at the same time. What more can you ask for? All right, a lot of solid throughout here. While this finishes cooling down, let's talk about the characterization a little bit. There are multiple techniques that we could use. Of course, as we've been talking about all semester, we're going to do IR, but we could also do NMR. We could do mass spec to make sure we've made the product that we wanted. Today we're going to do 2 characterization tests. One is IR, as I said, and the other is we're going to test it by reactivity, and this is something that we haven't done as much this semester, but is one that's commonly used. If I made the right compound, then it should behave in a particular way. That can be a spectroscopic behavior, or it could be a chemical behavior. And so we're going to try that. We're going to see if it behaves the way we want it to. I'm going to split my product, and I'm just going to be filtering it at 2 times in 2 different filters so that we can go a little faster.